will be talking about lipid catabolism. Before we get started, it is important to understand what lipids are and how they are digested, absorbed, and transported throughout the body. Lipids are non-polar compounds and are insoluble in water. They are used for energy storage, cushioning organs, and thermal insulation. Elmo and friends are really concerned of their good pal, the Cookie Monster, as he has been eating far too many cookies. Upon investigation, they have discovered behind how lipids are stored as fats.
It's a beautiful day. I'm going to go for a walk and look for my friends. Oh, what's this? It's a cookie. It's my lucky day.
Are you sure you want to eat another cookies? Haven't you had a whole jar already?
Of course, it's my favorite food. That's why I'm the Cookie Monster.
Did you know that cookies contain a lot of fat which is then stored in your body? I'm going to give you a lesson on how fats are digested.
Most of the process of fat digestion happens in the small intestine. Through the oral cavity, hard fats begin to melt. Once the cookie is swallowed, fats float as a layer above chyme in the stomach. When the chyme from the stomach is ingested into the small intestine, cholecystokinin signals the pancreas to release pancreatic lipase and the gallbladder to secrete bile salts into the small intestine. Bile salts emulsify fats and form micelles. Micelles increase the surface area for lipase to digest. Pancreatic lipase and intestine lipase cleave triglycerol to 3 fatty acids and 1 glycerol.
Elmo, you know nothing about the absorption. Let me explain. Scram! There are 5 steps for fat absorption. First step. First, the cookie is digested. Fatty acids and monoglycerides leave the micelles and enter epithelial cells by facilitated diffusion. Second, fatty acids are then used for triglyceride synthesis in the smooth endoplasmic reticulum. Third, chylomicrons are formed from the combination of fatty goblets and protein in the Golgi apparatus. Fourth, vesicles containing chylomicrons migrate to the basal membranes and are extruded from the epithelial cell and enter a lacteal. Chylomicrons are transported away from the intestine by the lymph in the lacteal.
What's this? What is cholesterol, transportation, and utilization? Cholesterol and triglycerides must be transported from the liver, where it is made, to the tissues where it is needed. This is achieved through special protein particles known as lipoproteins, such as chylomicrons, VLDL, LDL, and HDL. Lipoproteins consist of an outer water-soluble surface and an inner water-soluble core. The outer portion is made up of phospholipid, protein, and cholesterol, while the inner core is composed of triglyceride and cholesterol esters. Lipoproteins can be divided into 4 main categories, each with different portions of cholesterol and triglyceride. The lower the density of lipoproteins, the more fat contained within the particle. Chylomicrons are the largest and least dense of the lipoproteins. These particles are formed in the intestinal cell walls from dietary fat and cholesterol. Their main task is to carry triglycerides from the intestine to the tissues where they are needed as a source of energy. Another type of lipoproteins, which has a higher percentage of triglyceride composition, is VLDLs. Their main function is to distribute triglycerides to the target sites, such as adipose tissue and skeletal muscles, where they are used for energy and storage. On the outer surface of these particles are protein components known as apoproteins. They are involved in receptor recognition at cell surfaces and enzyme regulation. Apoprotein C2, located on the surface of both chylomicrons and VLDLs, and activates a particular enzyme responsible for triglyceride breakdown. Lipoprotein lipase catalyzes the hydrolysis of triglycerides into free fatty acids and glycerol. The glycerol component returns to the liver for glucose synthesis, and the fatty acid enters beta oxidation in peripheral tissues or is re-esterified as storage. Gradually, with the removal of triglycerides and protein, VLDLs are converted to LDL.
You're absolutely correct, Cookie Monster. Do you know about the transportation of LDLs? Low-density lipoprotein, LDL, is the principal form for cholesterol transport. The main function of LDL is to deliver cholesterol particles to cells for storage. Each LDL molecule contains a single apoprotein, B100, which is recognized by the receptors on the cell membrane, which initiates endocytosis. So how does LDL get into the cell after it picks up cholesterol particles from the bloodstream? The entry of LDL into cells uses a mechanism called receptor-mediated endocytosis. First, The receptor on the cell membrane sends its LDL through the recognition of apoprotein B100 and initiates endocytosis. Second, a pocket forms in the membrane. Third, LDL gets taken into cells, then an endosome is formed. Fourth, the endosome then fuses with the lysosome, which is the digestive enzyme inside the cells. The lysosome then digests the LDL and cholesterol esters are released. Fifth, the receptors are then recycled as it moves its way back up to the surface of the membrane. Final, the cycle continues until the concentration of LDL in the blood serum returns to normal range. Zoe, why did you tell Cookie Monster how it's actually regulated?
After the digestion of LDL molecules by lysosomes, free cholesterol esters are then released. Internalized cholesterol esters have three main regulatory effects towards cholesterol transport and utilization. 1. It suppresses endogenous cholesterol synthesis by inhibiting HMG-CoA Reductase. HMG-CoA Reductase is a rate-limiting enzyme in the production of cholesterols. This enzyme can be inhibited by suppressing its transcription or increases phosphorylation, which would inactivate this enzyme. Secondly, it also activates acyl-CoA, cholesterol acyltransferase, ACAT, which synthesizes cholesterol esters from cholesterol and long-chain acyl-CoA for storage. Lastly, it also regulates the synthesis of LDL receptors by lowering the mRNA content, which would ensure no uptake of cholesterol if there is too much in the cell.
Thanks for your concern, guys, but I'm really hungry. I'm gonna go grab another jar of cookies.
Cookie Monster!